Hello, everyone. I hope you all are fine and safe at your places. The topic that I'm going to discuss today is the structure of an atom. So, before I talk about the different models, before I talk about different theories, let's try to understand what this atom is. So, I have this piece of paper in my hand. If I start tearing this piece of paper into small pieces, a stage will come when I will not be able to break this piece further, break this piece further. So at that point of time, when I'm not able to tear this piece of paper further, this is called as an atom. So an atom is the smallest particle of matter. Now, there were different theories, there were different models, there were different things, experiments were conducted at that point of time to explain the structure and the behavior of the atom. One of the most popular theory was given by Dalton. There were 6 postulates in that theory, you must be knowing that. So in that theory, there was one postulate that atoms are indivisible. That means you cannot divide these atoms further. But nowadays we know that atoms are made up of electrons, protons, and neutrons. That means atoms are divisible. So later on, that postulate was not acceptable. So nowadays the atoms are divisible. Now, but do you know which of the famous scientists made this possible? The scientist who actually split the atom. He did not break the atom, but yes, he definitely proved that atom is not the smallest particle of the matter. Atom is actually made up of negatively charged particles, which are called as corpuscles. At that point of time, it was called as corpuscles. Later, it was named as electrons. He also observed that if you compare the mass of these electrons to the mass of an atom, the mass of these electrons are negligible as compared to the mass of an atom. Third important thing that he observed was no matter which material you are taking, which matter you are taking, the nature, the behavior, the properties of these electrons remains the same. Now we know the atom is neutral. So having these observation in his hand, he proposed a model, which is known as Thomson atomic model. So what is Thomson atomic model? Let's try to understand, and what are the different postulates given in Thomson atomic model. So before that, I'll just be sharing my screen quickly so that I can show you the picture. Give me a moment. Okay, so this is the structure of Thomson atomic model. It is also known as watermelon model. It is also known as plum pudding model. We'll talk about that why it is known as plum pudding or why it is known as watermelon model. But let's try to understand first that what this model is and what are the different postulates which are present in this model. So the first postulate is that an atom is made up of a positively charged sphere. And in that, the negatively charged particles are present. These particles are known as electrons. Nowadays, we know that these are known as electrons. At that point of time, when he proposed this model, the protons and neutrons were not discovered. So he said there is a positively charged sphere. He was not aware that what this positive sphere is made up of, but yes, there is a positively charged sphere in which the electrons are embedded. First postulate. Second postulate was that the number of these positively charged particles and the number of electrons which are present in this atom, they are same. That is how the atom is neutral. And the third postulate was that all the mass of the atom is uniformly distributed within the atom. These were the three postulates of Mr. Thomson atomic model, or J.J. Thomson atomic model. This model was accepted by many scientists, and this model was the historic in scientific history. Why? Because before this model, no concrete representation of atom existed before this model came into the picture. So that is about Thomson atomic model. It is also called as plum pudding model. Why it is called as plum pudding model? So if you see a plum cake, there is a base of the cake. So that base of the cake is representing the positively charged sphere of the atom. And the plum which is present in that cake, these plums are denoting the negatively charged. That means the electrons. Then why it is called the watermelon model? So if you see the red portion of the watermelon, if you cut the watermelon, the red portion of the middle watermelon is denoting the positively charged sphere, and the seeds of the watermelon, which are black in color, they are representing electrons. So that was all about Thomson pudding model, or Thomson atomic model, or plum pudding model. Along with that, though this model was acceptable and this model proved that that atom is electrically neutral because the number of positive and the negative charges are equal, so the atom is overall atom is neutral. But there were few limitations of this model as well. Now, what were those limitations? Number one, this model was not able to explain, or Sir Thomson, he was not able to explain that the negatively charged particle, or the electrons which are present in the positive sphere, they are present on a fixed position or they are moving randomly in the model. He couldn't explain that. Second important thing, at that point of time when he proposed this model, the discovery of protons and neutrons was not there. So he was not able to explain that. He said, okay, there is a positively charged sphere is present, but what is the constitution of this positively charged sphere? He was not able to explain that. So these were the limitations of Thomson's atomic model, and I've already spoken about the postulates of Thomson's atomic model. This model was highly acceptable and breakthrough in the scientific history at that point of time when Mr. Thomson explained this model. I hope I'm able to explain all the points, and I have covered all the points. Thank you so much. Thank you.